Okay, good day everyone. My name is Earl Warren Pidiparini, a BSAB 3 student, and today I'm going to show to you my oral board work video for strength of materials, focusing on the strain, specifically problem 213. I am very sorry for the rain. Rain is very strong. And the problem is the rigid bar AB attached to two vertical rods as shown in figure 15. Figure is a horizontal before load P is applied. Determine the vertical movement of P if the magnitude of P is 50 kilonewtons. So this is the figure here where the aluminum, the length is 3 meters, A is 500 mm, E is 70 gigapascals, and for the steel we have 4 meters length, area is 300 millimeters, E is 200 GPa, and distance from A to B is 3.5, and distance from B to C is 2.5. And we're going to find the vertical movement at P. So this is the free body diagram of the problem. Now to find the reactions of the aluminum and the steel. Let us first solve for aluminum. We're in moment at B. We'll go to moment at B is equals to 0. Clockwise is positive. We have their moment arm 6 RA minus distance 2.5 times the magnitude 50 is equals to 0. We have there 6 RA is equals to 125. Divide both sides by 6. RA is equals to 20.83 kilonewton. Now for the actual deformation of the steel, to find the distance, actual deformation, we have this formula here: force times the length over the area times the E. Plug in the values. We have here 20.83 kilonewton. Length is 3. This is in meters, so we have to use this factor of 1000 squared and divide by the area of the aluminum, which is 500, times 70,000, or the 70,000, the 70 GPa. To simplifying these values, we have here 62490 million over 35 million. The actual deformation for aluminum is 1.785 mm. This is for the actual deformation of the aluminum. Now let us move on to the steel. For steel, because the problem is because the beam is connected on two types of which is steel and bronze. Now for steel, we have the reaction for the steel here, which is on this side, so we have to moment at A. So summation of moment at A is equals to 0. So we have here negative 6 RS, the moment arm, counterclockwise, which is clockwise positive, counterclockwise, which is negative because it is counterclockwise. RS plus 3/5 no, 3.5 times the magnitude of the P, which is 50, is equals to 0. This would become 6RS 175. Divide both sides by 6. RS. Reaction at steel would be, which is 29.17 kilonewton. This is my second video for this evening. Now we have here the stress at steel. The actual deformation. Same with the formula as we did during the aluminum. PL over A times E. Plug in the values of P. We have here 29.17 times 4, which is the length in meters. We have to convert this in millimeters using the same factor as we did before. And the area is 3,000 times the 200 GPa, which is, we will convert this on MPa to cancel the values for the kilonewton. Simplifying, we have 116,680,000 over 60 million. 60 million. The first steel, the actual deformation of steel will be 1.945 mm. Now to plot these values, we are going to plot here. Okay, considering that this will be our baseline or the length of the beam. As for my problem, the rigid bar AB is attached to a vertical rod shown is horizontal before load P is applied. So this green line here is when load P is not yet applied, but when load P is applied, this will be the deformation. So we have here, this would be a value of, our value here would be the RA, which is the 1.785, and on the, okay, I forgot to write ABC. And for the C, we have here, for the steel, we have 1.945. So let's just denote this point here as 1.945. Now we are going to connect these two with a line. As you can see now, this is the distance here, 1.945, 1.785. Now, we are concerned to find the value. Okay, sorry for the pause. My phone storage went full and I have to transfer the file to my laptop. So the problem, we are just to find the vertical movement of B, meaning the vertical, so the movement from here to here. We already know that from here to here is 1.785. So, and this area is a trapezoidal in shape. So we are going to draw a straight line here to cut the plane into a rectangle and a triangle. And we are tasked to find the distance at here, so we are going to denote this as y. And we all know that this area here is measured 1.785. Now to find y here, since we are dealing at triangles, we can use the ratio and proportion method on finding the y. Ratio and proportion method, in which the height is equals to the base. Height equals height over base. So in this problem, we can denote that y here is the height, and the base here is 3.5. 3.5 is equals to the big triangle here, which is just 1.945, which is this portion here is 1.945 minus this portion here, which is 1.785. So 1.94 minus 1.785 over 6, given this cross multiplying, we have y6 is equals to 0.1635. So we will arrive at a value y being 0.56. I know, y6 0.56, being y is equals to 0.09 millimeters. So the distance here is 0.09 meters. But we are and to find the total distance, the vertical movement of P, so we have this vertical movement out of P is equals to 1.78, which is this portion here is 1.78 plus y, which is this portion here, as we solved earlier through the ratio and proportion method of triangles. So 1.78 plus 0.09, so the vertical movement of P is equals to 1.87 millimeters. And that would be for this problem. Oh my god, I solved 2 problems today because there was a change in instruction, so I have to adapt what is instructed, and still ipasa ra gyapon ako to na editing video so that I can submit today